6, Module 5, Lesson 11 says calculate the volume of the rectangular prism using two different methods. Label your solution, method 1 and method 2. Well, how are we going to be able to do method 1 and method 2? What does that mean? Well, let's do it probably the way that you'll do it and from here on out. Okay, this is the simple, I would say the logical way, the easiest way to do this. How do we find the volume? Volume is equal to length times width times height. And our volume is always cubed, right? When it's area, I say when you think of area, think of square area. Square area. You always square your answer. Here, with volume, it's always going to be cubed. Why? Because it's three-dimensional. Okay? Now, we just have to multiply these all together. So, for method 1, we'd say the length is 1 3/8 centimeters times the width, which is 5/8 centimeters, and the height is 2 1/4 centimeters. Now that's kind of hard to multiply together, right? So how can we make this easier? What? Oh, shut up. You're talking about do these first two numbers first? Well, let's do this first. Let's change these into improper fractions. Because I don't know how to multiply 1 3/8 times 5/8 by hand. So let's make it an improper fraction. That's 8 11/8, right? Times, we can leave it as 5/8. And then this would be, what's that, 8 9/4. Remember, those are all centimeters. So now we can multiply. Just multiply across the top and across the bottom. Well, what's 8 times 8? Times 4. You might need a calculator. That would be 256. Now, what's 45 times 11? 95. 495 centimeters cubed. Okay? Now we can divide that and figure out as a mixed number. But so now then, the easiest way to do this for the method 2, or the way they're talking about with method 2, is think about it like this. What is the common denominator that we would use for these fractions if we're going to add them? 8. So we would change this to 2 2/8, right? Have a common denominator. Now, the whole thing here would be how many 8ths cubes can we have? So an 8th by an 8th by an 8th. How many of these cubes can we have to go in this box? Okay? How many 1/8 cubes? So 1/8, 1/8, 1/8 cube. Got it? So let me do a fancy drawing here. Oh, got a little crazy on that one. If these were all 1/8, 1/8, and 1/8, how many of those can fit inside that box? Well, we've already got how many eighths is the 1 3/8, right? There's 11. See up here in the problem where we made it an improper fraction? It's an 11. So now we would have method 2 here would be 11 times how many for this? 5, right? There's 5 1/8 cubes in 5/8. Okay, so times 5. Now we need to figure out for 2 1/4, or as we said, 2 2/8. Well, how many is that? 16, 17, 18, right? There's 18 1/8 cubes in 2 2/8. Everybody understand how we got that? Just make it into an improper fraction. So now we have 19. So now then, if we multiply all those together, what do we get? $1,000. $11 times 5 times 19. 1,045. Oh, I thought you said 44. All right, so we have 1,045, right? But what do we need to do with that? Wait, what did I do at 19? I said 18 and then wrote 19, didn't I? Mr. Anderson never messes up, though. 990. There we go. Now, we have 990. But what does that mean? So is that the answer? Because we had 495 divided by 256 centimeters cubed. Well, that's not going to be 990. So what are we going to do? Divide by 2? We're not talking about triangles here. You got to think about what we're doing. We're multiplying by what? 1/8 by 1/8 by 1/8. So how much is that? This is going to be your numerator here. Now, what is your denominator? What is 8 times 8 times 8? 512. Now look, this is equal to 495 if you divide it by 2. It'll reduce down to that. So we know that our answers are the same. This answer and this answer, of course, is equal to that. So we need to put centimeters cubed. To me, that's a lot more work. I would probably just do method 1, but if it asks for method 2, that's how. You'll find the common denominator and see how many of those little boxes we can put in there. Okay?